readings we'll do more examples like this, but this is quite an important thing, named basically substitution and limits. And also there is this important limit that we should remember, and that is sinus x over x as limit of x goes to 0 equals 1. So we can use this sine of x over x as x goes to 0 equaling 1 to solve this thing actually quite nicely. So let's see. Actually, so this is separate from it, but we'll make this equal to something, and I'll choose the following substitution, that y equals x minus 2. Well, that will help me get a form gradually that will look very similar to this. So we have we'll find some sort of sine y over y. So let's see how it goes. So if y equals x minus 2, then if x was going to 2, then we have limit of y goes to 0. Because we have it shifted like this, right? We said y equal to x minus 2. So we now have to subtract 2 from everything where there was x concerned. Also, I will rewrite it right here. So I'll have pi times y minus 2. And also we'll have y down here. But now let's consider what this means on the top. We have y going to 0 and sine of pi y minus 2 pi over y. But let's rewrite this a bit more for this to be more clear, and that is sine of pi y minus 2 pi. If you have a even multiple of pi, if you look at pi, we have it something like this. If you have an even multiple of pi, you sort of get after 2 pi, so this is 1/2 pi, 3/2 pi, 2 pi, to the same sort of segment. It's a repetitive function. So if you have not an odd multiple of pi, but an even multiple of pi, natural number added, an even one, which we have right here because of the 2, if it was 1, then it would be different. But because it's even, it's like it doesn't have an effect. It's like multiplying by 1. So, because we know this property of sine, it's not a general observation. If it was even, we would perhaps multiply by -1 here. But because this is, we can rewrite this argument inside py minus 2 pi. Adding or subtracting an even number of pi's doesn't change the argument of the output of the sine. So this is actually same as sine of pi y over y. We also adjusted the limit bound here to 0, and now it really much matches this limit as something goes to 0 of sine of that variable over the variable equaling 1. And what we go there directly, so actually this is equal to 1. And let's also check one more thing. What happens if, so I mean as if we have the substitution, we should also check what happens. So as if x goes, we should always think about this. So x goes to 0, then y goes to -2, or if x goes to 2, y goes to 0. That's how we got there. That's first thing. Also, we should check that x minus 2 should not be 0, so y should not be 0. Y actually approaches 0, but it doesn't go to 0. So as y goes to 0, x minus 2 approaches 0, but it's not exactly 0. We want to have also a defined denominator here. But anyway, the substitution was the main point.